Okay, in this video, we're going to be taking and translating a one-step linear equation into words, into a word problem, or a word problem change or translate it into an equation, a one-step equation. In this problem right here, we're supposed to pick the following scenario that best represents this equation right here, which has a division. We're dividing by 13. The division is to separate, is to cut up into equal parts. So let's take a look at the first one. First statement, Sam started with some desks. After he separated them into 13 piles, each pile had 34 desks. That one looks pretty good because he started with some desks. We don't know. And notice here a variable is used for what we don't know. And he separated them into 13 piles. That would be like dividing by 3. And then each pile had 34 desks, and that's what equals me, equals 34. So I think that's going to be the one right off the bat. Let's check the others. Sam started with 34 desks. After he separated them into some piles, that means he divided them into some unknown piles. So that would be 34 divided by a variable. That's not what we have up here, so it would not be that one. Definitely cross that out. The next one, Sam started with some desks. So again, we have a variable. He started with some desks, which is the x. He separated them into 13 piles. That looks good. Divided by 13. Yep, just what we have right there. He had 34 less desks. Less desks. It means like he subtracted 34. I don't know about that one. It started out looking good. Very similar to the first one we liked. But then 34 less desks. All right, let's check the last one. He started with 34 desks. Separated them into 13 piles. That would be 34 divided by 13. That's not what we want. So I'm going to go with the first one. Pretty sure because he started with some desks, separated them into 13 piles, and the result, the answer, which would be equal to, is the 34 desks. And it's correct. And the reason we're getting hearts is because I'm doing this video on Valentine's weekend. All right, this next example. Sam is getting ready for his grandson's birthday. He divides a jar of cookies evenly among 9 goodie bags. Each bag ends up with 3 cookies. Which equation can be used to determine the number of cookies in the jar? So the cookies are the x. He divides a jar of cookies evenly among 9 goodie bags. So he's dividing among 9 goodie bags. So I'm thinking, could that be divided by 9? That's right here. And in each bag, he ends up with 3. And we're supposed to use x as a number of cookies in a jar. So he started with how many cookies in a jar. He put them into 9 goodie bags. Each bag had 3. So that fits the very first example. Next problem. Ray's preschool teacher, while she was getting ready for her class's snack time, she put 6 plates on the table. If she placed 48 total grapes on the plates with an equal number of grapes on each plate, then which equation could be used to determine the number of grapes x? Well, let me stop the video. I messed something up. I'll be right back. Oh my, I must have tapped something too many times. So the x represents the number of grapes on each plate. And there were 6 plates on the table, and there's 48 total grapes. So she had 6 plates, and she's putting x on each plate. So 1 plate, that'd be 6. 2 plates would be 12. So you're multiplying together the x and the 6. And then you would have a total of 48. you could use that equation. You divide by 6 on both sides, get x equals 8. So it should be putting 8 grapes per plate. So that's the equation that would make sense for that situation. Let's do one more. See how we do. Which of the following scenarios matches this equation? We have 98 is equal to something times 14. So in the first sample there, Winston started with some necklaces. He had some necklaces. That would be the variable. If he collected 14 more, if necklaces are the variable and he collected 14 more, that'd be like adding 14. So that's not what we want. Second scenario, Winston started with some necklaces. That's like the x, the unknown, the variable. If he increased his collection 14 times over, he had 98. That would mean it would equal 98. And 14 times the number he already had, which was x, that fits the scenario. Before I hit the green check, I do want to look at the other examples. Winston started with some necklaces. That's like the x. If he increased his collection 98 times over, so you'd be multiplying by 98 times x. That's not what we have. Don't want that. Last choice, Winston started with some necklaces. So again, that would be the unknown. If after he collected 98 more, that'd be like adding 98 onto that, and that's not what we want. So it's definitely going to be the second one. Great. Good luck with those.